right, class, thanks for being here. Go ahead and find your seats. We're going to begin class shortly. Before we start with our main lesson, we're going to look really quickly at a review of what we learned last time. So does anybody know what the divisibility rules are? Can someone tell me what they are? Yes, Chloe.
Divisibility rules are the rules on how to divide, like how 2 can go into any number that ends in 0 or the last digit is even.
Yes. So right here we have a list of the divisibility rules, and you can see the one that Chloe just told us, that 2 is divisible, or can divide into any number that's last digit is even or is a 0. Other ones might be 5, the last digit is 0 or 5. 5 can divide into them. So they're just like quick ways to look at a bigger number and see if it's actually able to be divided by one of these numbers. So really quick, we'll see what is 56 divisible by using our divisibility rules. Does anybody know?
2,
Yes, Chloe.
4, 7, and 8.
Might not have heard her. It's 2, 4, 7, and 8. So why is it divisible by 2?
Because it's even.
Yes. And then 4, 7, and 8 weren't very helpful with, the rules weren't very helpful with the number 56 because it is the last 2 digits, which is only 2 digits, last 3 digits, only 3 digits, so it's just long division. But it is divisible by those. So if you do encounter that where the rule is not technically helpful, you still just need to divide the number using long division to find the answer. So we're going to hop into our lesson about the greatest common divisor. So the greatest common divisor is known as the GCD, and it also could be known as the greatest common denominator. It can be known as the greatest common factor, or it could be known as the highest common factor. But in our lessons, we're going to refer to it as the greatest common divisor, and that's what you're going to see on your tests and homework. So the GCD, what is the greatest common divisor? And how do we find that? How do we find the greatest common divisor? So we have to prime factor the numbers we're trying to find the GCD for, and then we're going to find the biggest share, the biggest common factor or divisor between them. So can someone tell me what a factor is? What is a prime factor?
It's a number that can't be broken down anymore.
So it's a number that can't be broken down anymore. So the definition is that you cannot multiply 2 numbers together to get that number. The only thing that you could multiply together to get that number is itself and 1. So for 5, you can't multiply 2 numbers together to get 5. You can only multiply 5 times 1, and therefore 5 is a prime factor. So we're going to try to find the GCD of this. So we're trying to find the greatest number that we can divide evenly into both 50 and 30. So how are we going to do that? We're going to prime factor. Now, how do we prime factor? We're going to use what's called a factor tree. And so we're going to just go down the line and we're going to see if we can get 50 down to its prime factors, the smallest numbers that are multiplied together to get 50. So the way we're going to do that is we're going to look at 50 and we're going to see, okay, so 50 is divisible by both 5 and 10. So if you multiply 5 and 10, you're going to end up with 50. And I'm going to split those just for the sake of my board, switch those around, so this is 10. Now, we're trying to find prime factors. So we already talked about it, 5 is a prime factor, but 10 is not a prime factor. So we're going to split that down into prime factors, and we know that 2 times 5 equals 10. And so then these are going to be our prime factors for 50. We're going to end up with 2 and 5 squared. We're going to do the exact same thing for 30. We're going to look at 30 and we're going to think, I know that 30 can be split down to 10 and 3 because 10 times 3 equals 30. And then we're going to do the same thing for 10 because 10 is not a prime factor. And we're going to get 5 and 2. Now these are our prime factors. So we're going to have 2, 3, and 5. Now, how do we find the GCD? So we have all these prime factors, but what is the GCD? The GCD is the greatest common divisor, the biggest number that is common in both of these that can be divided into them evenly. So we're going to look and we're going to find common numbers. So we have 2's here. Right off the bat, we see 2 2's, one on either side, and so we're going to grab a 2. And then we can see that there's also 5's. Now we can't use 3 because 3 is not on this side, but we do have a 5 on this side and we have a 5 on this side. And so we're going to get 2 times 5, and that equals 10. So we're going to get 10, and that is going to be our GCD. That means that that is the biggest number that you can evenly divide into both numbers 50 and 30. Now, why couldn't you just stop once you saw 10? Because you had 10 here, and you had a 10 here. I'll go ahead and to the next slide. You have this 10, you see this 10. You could just stop there, and you could just say, okay, well, I know that that's 10. But in these numbers, that might make sense because these are prime. So we know that those are prime. But if this was a 6, it's a horrible 6. If that was a 6, and this was a 4, and we said that 10 is our biggest number, and these would be 50, this would be 60, and this would be 40. And we said 10 is our biggest number, that would be wrong because these still need to be split. So we would still need to keep going to find. So it's just best if you completely prime factor, unless you know that the number sitting next to it is a prime number, and then you can find it. But an easy way to check is it's 2 times 5 times 5, 2 times 3 times 5. That should equal the number that you started with. It does not equal the number that you started with, then you did it incorrectly, and you need to start over because that's not the correct prime factor. No matter how you do it, those numbers multiplied together should equal the number you started with. So the greatest common divisor for 30 and 50 is going to be 10.
We're still filming. Okay.
So the greatest common divisor is going to be 10 for 50 and for 30. So what is the practical use for this? When would you ever use the GCD? Good question. So the GCD is the biggest number that you can divide two numbers by evenly. So this could be useful if you had, we'll use the same example, you had 30 over 50 as a fraction, and your teacher says, you need to make sure that this number is simplified. Well, how do you simplify that? Well, I guess you could look at them and you could say, oh, this is a 0, this is a 0, I know that 5, or I know that 2 can go into that, so I'm going to do that. I'll divide it by 5, and then I'll go through my whole thing. Or you could find the GCD. You could find the GCD, and we know that the GCD is 10, and you could divide them by 10, and then you would get 3 over 5, and you know that that number can no longer be simplified because you put the GCD to it. This is the biggest number that is going to go evenly into both of those numbers. And so that is definitely simplified. So that's one way you can use it when you're doing fractions. That is just super helpful. So that's why we find the GCD. So what do we not want to do? What do we not want to do when we're finding the GCD? So we do not want to find the numbers that form a sum. What is a sum?
It's when you add two numbers together.
When you add two numbers together, you get a sum. So this is adding. We want to find the numbers that multiply to form the product. What is the product?
You multiply two numbers together.
You multiply. So the product is multiplication. So this is adding, this is multiplying. We want to find the numbers that multiply together. So in my example with 30, if I had found the numbers that add up to create 30, I would have been wrong. If I had come up with 10 and 20, this is wrong. Those are the numbers that add up to create 30. That's why when I came up with 3 and 10, that's right, because 3 times 10 equals 30. So we're trying to find the numbers that, when multiplied together, they equal the number that we originally started with. We do not want to order the numbers incorrectly. We're going to go back really quick and look at my numbers. I did 2 and then 5 squared. I did 2, 3, and 5. We're going to want to keep our numbers in order from least to greatest. Now, that doesn't really make a difference. We know that if you multiply 5 times 2 or 2 times 5, it is still going to equal 10. But when you have a big number that you are finding the GCD for, and you put them all sorts of places, and you did 5, and then 2, and then 3, and then 8, you wouldn't have 8. But if you did them in that order, then you would be incorrect because you would have a really hard time finding the numbers that you needed So it's just best if you keep them in the correct order. I will ask you to keep them in the correct order on your tests, so just get used to keeping them in the correct order. So we don't want to find the biggest number, we want to find the biggest number that divides evenly into a set of numbers. So really quick, we'll look at 65 and 70. Now the biggest number is 13, because we know that 13 times 5 equals 65, and then 70 times is 10 times 7, and then 2, and then 5. So these are our prime numbers. Our biggest number here is 13. 13 is by far the biggest number here. But 13 cannot be our GCD because 13 doesn't go into 70. So we're not just trying to find the biggest number, we're trying to find the biggest number that is common, it's shared. So whenever you're thinking about this, just remember that it's in common. We're trying to find the biggest common divisor, not just the biggest divisor. Okay? Moving on, we do not want to confuse the GCD with the LCM. So we're going to talk about the LCM later in future lessons. But for right now, I just want you to remember that if you have a problem, if you're looking at this and you're thinking it's just a set of numbers, or I'm sorry, it's a set of letters and I can't remember what it means, is this the greatest, like what is it talking about? Think about what it stands for. Just think about what it stands for. It is greatest. What does greatest mean? What is another word we could substitute for greatest?
Biggest.
Biggest. We could say this is the biggest. So we are looking for the biggest number. Common. What is common? What can we use for common? It's a synonym for common. How about shared? Shared. It's in both. This is a common. And then D. What does D stand for? It stands for divisor. Now, what in the world is a divisor? Does anybody know?
You can do something that divides into.
Yeah, it's the number that divides into. So in a, if I had 30 here and I had 3 here, this is the divisor. It divides into. So when you're looking at it, it's going to be a smaller number than the number you end up with because it's dividing into it. So it's a number that makes up the bigger number. So it's always going to be smaller. So just, if you're sitting there and you're overthinking it and you're wondering what you're doing, and you can't remember what the GCD is, think about what the letters stand for and what they mean in words that you would use normally. So greatest, shared, and so on. But you do want to make sure that you are giving me the GCD and not the LCM when I ask for the GCD. Really quick before I move on, this says here, it says evenly into a set of numbers. The GCD can be found for more than just 2 numbers. You can find the GCD for 100 numbers if you want to. It would take you a really, really long time, but you could do that. So it's not just 2 numbers, not limited to 2 numbers.
We're still filming.
Okay, so we're going to look at a couple of examples. So we're going to look at 25 and 40, and I'm going to show you a different way that you can actually do this besides the prime factor tree, which I showed you before. So I'll show you 25 with the prime factor tree, and then we'll do 40 with short division. So 25, what can we split 25 into? What can we find for 25?
5 and 5.
5 and 5. Now, are we done with 5 and 5?
Yep.
Yes, we are, because 5 and 5 are both prime numbers. So we're going to end up with 5 squared. Now 40, there's a different way you can do this. You can actually do this with short division. So I can put here, what can I put into 40?
5.
Yes, we can put 5 into 40. So what do we get then?
8.
Yep. Oh gosh. Yep, we get 8. So then we're going to keep going. We're going to take 8, and what can we divide 8 by? 2. All right, what do we get now?
4.
4, and what can we divide 4 by?
2.
Sorry, I have something in my throat. 2, and then we get 2. So we can do it this way. No matter how you do it, you are going to come up with the same answer. If I did it this way, I would still get 2 to the 3rd and a 5. And over here I got 2 to the third and a 5. This you just have to remember that you can only put prime factors here. So I couldn't say, oh, 10. That would be incorrect. I can't do that. I have to do 5, or I had to do 2, because I can't put a number that's not a prime in that place. So that's another way you could do it if that looks easier to you, or if it's just more common to you. You can do it that way if you would like to. So now let's find the GCD. How do we find the GCD? What numbers are we going to pull into our middle that are common?
5.
5. Can we pull any other numbers?
No.
No, because 5 is the only number that we can find on this side, and we can find on this side. We don't have a 2 over here, so we can't put it there. Good job. All right. Let's keep on going. Oops. Something happened. Looks like we're fine now. Okay, so this is the same one as GCD is 5. We're going to do 45 and 60. So 45 and 60. What can we do to 45? What can we split 45 down into?
9 and 5.
9 and 5. And we can use our divisibility rules here. That's why you learned them before. We can look, we can see that this is a 5, so we know 5 can go into this number. It's a horrible 5. Let me erase that. We know that 5 can go into this number, and then we just need to find the other number. So we have 5 and 9. Are we done if we end there?
Nope.
No. What can we do to this number? What is not a prime?
9.
9 is not a prime. What can we split 9 into to make it prime?
3 and 3.
3 and 3. Are we done now?
Yep.
What are our prime numbers?
3 squared and 5.
3 squared and 5. So we have 3 squared and 5. And notice, keeping my numbers in order. Okay. So we did 45. We get 3 squared and 5. Now we're going to do 60 with short division just so you guys get used to it. So what can we do to 60? What can we divide 60 by? That's a prime number. 5. Remember, they do have to be prime numbers, otherwise this doesn't work. And you can go ahead and circle that, just so you know where your prime numbers are. What do we get left?
12.
We get 12. What can we divide 12 by?
3.
3. That's a prime number. We can go ahead and circle that. So what do we get when we divide 12 by 3?
4.
4. Is that done? Are we at all prime numbers now?
Nope.
No. So what do we do with 4?
Divided by 2.
Divided by 2. And then what do we get?
2.
2. Okay, so then these are our prime numbers. And once again, you could do this the same way with a prime factor tree, and you would still get 2 squared, 3, and 5. And if you need to figure that out, if you look at this and you think, maybe that's not right, you do 2 times 2 times 3 times 5, and that equals 60. And if that does not equal 60, then you did your math wrong, and you can do it again. But it's a really quick and easy way of checking yourself, and I would suggest that you do check yourself so that you can catch any mistakes that you have. So, what is our GCD then? What numbers do we have that we can pull into this middle?
3 and 5.
3 and 5. So then we have 3 and we have 5. We can't take the exponent on this 3. We can't take 3 squared because there isn't a 3 squared here. So we only can take our 3. So we have 3 and we have 5, and that equals
15.
15. So then our GCD is going to be 15. Great job. I think we have time for a couple more problems we can run over. So there's that, just showing that our GCD is 15, and this is how we got there. All right, so 16 and 32. What can we do to 16?
2 and 8.
2 and 8. I need to work on my 2s. There we go. 2 and 8. This is a prime factor. Is 8 a prime factor?
Nope.
No, so what do we do to 8?
Bring it down to 4 and 2.
4 and 2. Okay, can we finish that?
No.
No, what do we do?
Break it 4 down to 2 and 2.
2 and 2. Okay, so then these are our prime factors. So what do we end up with? A lot of 2s, right? How many are there?
4 2s.
Yeah, so 2 to the 4th. And we are going to write them this way because it is easier than writing 2 and 2 and 2 and 2, and this means the exact same thing. It's just a simplified form of that. And we went over that in past class. Just to reiterate, please write them that way. All right, so 32, we're going to do this one this way, just so you guys get used to it. So what is 32 divisible by?
2.
2. And remember, they do need to be prime. So that 2 is prime, so we can use that. What do we end up with then?
16.
16. Okay, so what can we divide 16 by?
2.
2. What do we end up with?
8.
8. What do we divide 8 by?
2.
And what do we end up with?
4.
Okay, and what do we divide 4 by?
2.
And what do we end up with?
2.
2. So then we end up with all of these 2's. How many 2's do we have?
2 to the 5th power.
2 to the 5th power. So now what is our GCD? How many 2's are we going to end up with?
4.
We're going to end up with 4 2's. So that's 2 times 2 times 2 times 2. What does that equal?
16.
16. Okay, so then our GCD is going to be 16. Just remember that we do need to take all of the shared numbers. So even though we had 2's over here, we had 2's over here, we couldn't take 5 2's because we only had 4 2's on the other side. So they do need to be shared, not just the number, but also the amount of that number. So we see 2 4's, or 2 to the 4th and 2 to the 5th, and we got 16. So we're going to play a quick game. It's called I Have. So what we're going to do is I have index cards, and on them they have an equation, and on the other side, on the front of them, they are going to have a number. So maybe they will have 5 on them. And then on the other side, they are going to have, maybe they'll have 20, and they'll have 15. And you're going to figure out what is 20 and 15's GCD, and then once you figure that out, we're going to start. So once everybody figures out the back, we're going to start our game. And how it's going to go is that on one side you're going to have a smaller number, so you're going to have like 5, or you're going to have like 3, or you might have 10 or whatever, and you're going to say what your GCD for your numbers are. You're going to say, so for this one, we have 3 and 5, and then we have 5. That's not what I wanted to do. We can do that, but let's do this. 10, 2, 5, and 2. And so then our GCD here is going to be 5. So then I would say I have 20 and 15, and the GCD for that is 5. Who has 5? And so then whoever has 5 on the other side of their card, they're going to say, I have 5, and then whatever their GCD was. And we'll go around and it will come back to the beginning. So we'll go ahead and do that really quick. Great job, guys. That was a fun game. So what is the GCD of 45 and 54? So 45 and 54, and I'm going to ask some volunteer to come up and do this, but before we do that, I would like everybody to sit down, and I'm going to have you guys write down, go ahead and do that, and then I'll have a volunteer come do that. So does anybody feel confident that they would like to come do this? Chloe, you do? Here you are. And while Chloe's doing this, you all should be doing it on your paper as well, just so that we get the same. 27. What do we think 27 is divisible by? Should try 3. And this is where we can also use our divisibility rules. We can look at 27 and know that if we add 7 and 2, we will get 9, and we know that 9 is divisible by 3, and therefore 27 is divisible by 3. And then, not to call you out, but how do we write our numbers?
Oh my word.
We write them in order. Okay. So what is our GCD? 3 squared. So what is that? 9. Perfect. So our GCD for 45 and 54 is 9. Thank you. Good job, Chloe. Thank you for doing that for us. And if you did not get 9 on your sheet of paper, multiply the factors that you found and make sure that they do equal the number, and just recheck it, make sure that you did that correctly. And as you can see, this is how she got there, and the GCD is 9. So right now I would like you guys to grab your iPads. We're going to work on lesson 4. It says GCD on there, and we're going to work on that for a little bit, and I'm going to walk around and make sure you guys are working on the GCD. If you have any questions, please feel free to ask. Go ahead and get started.